This is your homework, and your job in this homework is to label every single type of energy that you see in the initial and the final state. I'm actually going to do this first example for you just to kind of have you label. Now they say EINT. I suppose I could go back here to the picture and I'll call this EINT as well. You can call it ED for dissipated or EINT for internal. It means the same thing. Now here's the idea. Here is a train. That's supposed to be a spring. And look at this. At the top here of the loop-de-loop, it's moving and it has height. So what energy do I start with? A compressed spring. That means I have 4 blocks worth of elastic energy. Now what happens to that elastic energy? Well, if I look here, I see that it's gone all the way up to the top here. And so it looks like I have quite a bit of gravitational energy, and I'm also moving. So what happened to all this elastic energy? Well, it looks like quite a bit of it has become gravitational energy, and it's also got some moving or kinetic energy. Let's remember EK is moving, and EG is gravitational. Okay, just to kind of remind you. Now, one thing people ask, they say, how did you know to put 3 blocks of gravity energy? The truth is, I didn't. What I do know is I'm really high up, and that means I would have slowed down a lot. So I'm going to assume that most of my energy is gravitational, and only a little bit of it's moving energy. So here's the rule. You notice I have 4 blocks of energy here. That's 1, 2, 3, 4. That means I have to have 4 blocks of total energy here on the right side. That's the one rule that we follow. Now let me give you a second example just to kind of go through this. Look, I've got a spring. And again, all my energy is stored as a spring. How do I know this? Because I have no height and I have no motion. Now what happens to my energy? Well, look, compared to number 1, I'm a little less high up, so I'll only give myself 2 blocks of gravity energy because I'm less high up. And that means the rest of my energy has to be stored as kinetic energy. What it means is it might be moving a little bit faster here as well. So in other words, these 4 blocks of elastic energy get converted into 2 blocks of kinetic and 2 blocks of gravitational. Why did I say 2 and 2? Again, the most important thing is not the number of blocks. It's that the total number of blocks here equals the total number of blocks. And what I mean by a block of energy is this is 1 block, this is 2 blocks, 3 blocks, and 4 blocks worth of energy. Just so you know. So that's basically what you need to do for this entire worksheet. I want you to take a look at this. And you know what? I'll actually have you guys, if you can do me a favor, pause the video and let's try to do number 3 together. So for number 3, the energy that you start off with, it looks like you start off with a height of 0, but your speed's greater than 0. So it looks like all my energy is kinetic to start with. Now what happens near the end? V equals 0. That means I have no kinetic energy at the end, right? And I have a height greater than 0. Now I'm going to do something interesting here. I'm going to say, wait a minute, all my energy is gravity except maybe there was some friction acting on the car. So what that means is some of my energy got wasted as friction in the road. And I'll fill in, again, I got a total of 4 blocks to start with. And I've got 4 blocks here, total. So this is kind of a basic introduction to these energy graphs. Your assignment is to finish this entire worksheet all the way to the end of problem 6. Now here's the deal. You may or may not be able to get 1 through 6 done perfectly, but I do expect you to make the attempt and come to class with those. And basically, for us to be able to do the roller coaster project in class, I have to see that you've done this. I have no problem spending the entire period just doing this, but I'd like to have some fun and do the roller coasters. So we're going to go over this tomorrow. or friend.